Before digital computers, engineers solved equations using gears, spinning wheels, and even flowing water. In fact, some of the earliest computers didn't use code at all. They used physics. These machines were called analog computers, and for a time, they were some of the most powerful problem-solving tools humans had ever built. One famous example was the differential analyzer, developed in the 1930s by Vannevar Bush Schmidt. This massive machine used rotating shafts, gears, and mechanical linkages to solve complex differential equations, the kind of mathematics used in physics, engineering, and ballistics. Instead of calculating numbers step by step like modern computers do, analog computers represented problems using physical quantities. A rotating wheel could represent velocity. Electrical voltage could represent a variable. Even water levels could represent changing values in an equation. In other words, the computer didn't just calculate the equation, it became the equation. During World War II, analog computers played an important role. They were used to aim anti-aircraft guns, simulate aircraft movement, and solve engineering problems in real time. And the biggest advantage: speed, because the system was physically modeling the problem. It could produce answers almost instantly. Pretty impressive for machines made mostly of metal shafts and gears. But analog computers had a major weakness. They were extremely sensitive. Tiny imperfections in the gears, temperature changes, electrical noise, or even dust could introduce errors into the results. And while they were excellent at solving specific types of equations, they weren't very flexible. Reprogramming an analog computer often meant physically rewiring the system or rebuilding parts of the machine. Imagine updating your laptop with a wrench. Then digital computers arrived. Machines like ENIAC showed that calculations could be done using binary numbers, ones and zeros. Instead of physical measurements, digital systems were far more precise, easier to program, and capable of solving many different types of problems without rebuilding the hardware. As transistors and microchips improved, digital computers became smaller, cheaper, and dramatically more powerful. By the 1970s, analog computers